We're now going to apply our understanding of KVL and KCL, starting with the former using mesh analysis. A mesh is just a special type of loop in a circuit that doesn't have any other loops inside of it. Consider it the elementary loop. If a circuit can be redrawn to have any intersecting disconnected lines, then we cannot use mesh analysis. We want to obtain the mesh equations to be able to interpret the circuit. Firstly, we apply KVL to each mesh in the circuit. Secondly, we express the voltages of the elements in terms of the mesh currents. Here is a basic circuit incorporating a voltage source and 3 resistors. Note that the circuit is grounded. This circuit has 2 meshes in it. The currents I1 and I2 are the currents about each mesh. In places where the currents affect each other, seen here at the 40 ohm resistor, we take the sum of the currents but consider the direction. Here, if we examine the left mesh, the current through this resistor will be I1 minus I2 because I2 is going in the opposite direction to I1. The method behind mesh analysis is to examine the mesh in terms of the voltages of each element and express that with the mesh currents. Using Ohm's law, we can express the voltage across the 10 ohm resistor as 10 ohms multiplied by I1. We then use this approach across a circuit applying KVL to find the mesh equations. Note that in mesh 1, the 10 volt drop across the source is written as a negative. This is because we have set our mesh direction to be clockwise. Therefore, our drops across the 10 ohm and 40 ohm resistors have been positive. Continuing around in this same direction, you can see that a voltage drop from ground at 0 volts to a positive 10 volts will be written as negative 10 volts. Then we can use these simultaneous equations to solve for the unknown current. We can finally return to expressing the voltages of the elements in terms of the newfound current value.